real quick video review, shaky camera here, of the review for Chapter 6 and Chapter 7. Starting on your final exam review number 131, solve this system using substitution. So here's one line goes up, one line goes down. I want to find the x, y where they cross. If you choose to use substitution, you need to get x or y alone. Now I chose this equation and I'm going to get this x alone. So I start by moving the 3y over and it looks like this. Then I divide everybody by 4 and it looks like this. So what I have is an expression that says x can be replaced by, that's what equals means, x can be replaced by this expression right here. Go to the other equation, not the one you were working on, but go to the other equation, find x right there, and replace x with this expression here. So it's going to be 3 parentheses, and then I'm going to replace x, and it looks like this right here. 3, I took out the x and replaced it and copied the rest of that line. The rest of it's just a little math. Multiply to get rid of the parentheses. Add like terms. This y and this y can be added together. Just hit -9/4 minus 4 on your calculator and you get this. Move this fraction over here, so -39/4 minus 39/4 gives you this. And then I usually just divide the fraction away from the y. So divide by -25/4, divide by -25/4. And you can do that on your calculator. Use your fraction key, -23 fraction 4 divided by -25 fraction 4 gives you this for the y. Now that we found y, we need to go back and find x. Use either one of your original equations. I chose equation 1, and I'm going to replace y with 23/25. So replace y with 23/25. Multiply to get rid of the fraction, you get this. Move that fraction to the other side, so plus plus gives you this equation. Divide by 3 gives you this. So final answer, x, y, ordered pair. Elimination method, same problem, is a little shorter usually. So same equation, same system, same two equations. I chose to get rid of y because I like that this is negative and this is positive already. All I got to do is find a number that 4 and 3 go into, and that's 12. So this one needs to get 3 times bigger, and this one needs to get 4 times bigger, and my y's will cancel out. So multiply equation 1 by 3, multiply equation 2 by 4. You get these two equations here. Same two equations, just a little bigger. Add them together, the y's cancel out, they eliminate. 25x equals 64, x equals 64/25. Now I got to find its partner y, so I chose to go back to equation 1. I replaced x with 64/25, looks like this. Multiply to get rid of the parentheses. Now move that fraction over here, so -192/25 minus 192/25, and then divide by -4, divide by -4, you get the y. Same answer, a little bit shorter. And then just for grins, I solved the same thing using Cramer's rule, so this is kind of a review of 7 at the same time. Same system. Your x numbers are 3, 4, your y numbers are -4, 3, and your answer numbers are 4, 13. The original d determinant is your x numbers and your y numbers. dx, the x numbers got replaced by 4, 13 right there. And dy, the y numbers got replaced by 4, 13 right there. Calculate these by doing down product minus up product. The down product, downward diagonal, 3 times 3 is 9. Upward diagonal is -16. And you want to subtract them to get 25. Down is 12. Up is -52. So 12 minus -52 gives you 64. Down is 39. Up is 16. 39 minus 16 is 23. Set it up like dx over d and dy over d will give you your x fraction and your y fraction. Here's another example, 2 different lines. All right, I chose to use substitution, and I'm going to isolate this x right here. So I start by moving the 8y over to the other side, and then divide by 6, divide by 6, divide by 6 gives me this expression here. X can be replaced by this. Oh, I forgot, I need to reduce 8/6 to 4/3. So x can be replaced by this expression here. Now go back, don't use the equation you were working on, go back to the other one, find x right here, and replace it with this expression here. So 3 parentheses, and then replace x. Looks like this. Multiply to get rid of the fraction, or to get rid of the parentheses. Add like terms, and your y's actually go away. They turn into 0. So you're left with 11 over 2 equals 7. Well, 11 over 2 does not equal 7, so of course that's no solution. Same problem using elimination. Notice it's a lot shorter. I prefer elimination, but you can use either method. I chose to get rid of the x. To get rid of the x, this one needs to be -6, which means I need to multiply row 1 by -2. Row 1 becomes this. Row 2 came over as is. I canceled my x's, which I meant to do, but my y is accidentally eliminated. So I look at what I have left over. I have 0 on the left and -3 on the right. Those do not equal. That's no solution using the elimination method. Okay, another system you might run into. Here's the first line, here's the second line. I'd definitely use substitution on this because they've already isolated the y for you. So I'd look at this and say, okay, y can be replaced by this expression here. So I go to the other equation, locate y, and take y out and replace it with this expression. So 2 parentheses and replace y with this. Looks like this right here. Multiply to get rid of the parentheses. Notice the 5x is not involved. I'm just multiplying everybody by 2. And I get this right here. 5x minus 5x goes away, turns into 0. 20 equals 20 is true. And if it comes up, if you accidentally eliminate everything and you have a true expression, that means there's a bazillion solutions, infinitely many solutions. Same problem using elimination. It's not really that much shorter this time, but same system. Now, first, before I can use elimination, I got to have my x's and y's lined up. So this x needs to come over here and get lined up with the other x. So I bring the 5 over 2x over here. Now it's positive 5 over 2x. Now everything's lined up. I choose to get rid of y because it looks easy if this was a -2. So I multiply row 2 by -2. It gives me this row 2. I brought row 1 over as is. Wind up with 0 equals 0 again. Infinitely many solutions. By the way, guys, don't study 134 and 135. That's the 6.3 section. I'm not going to put that on the test. All right, and number 136, we have an XYZ system, a 3-variable, 3-equation system. First step's add any 2 rows and eliminate x. Second step is add 2 other rows and eliminate x. So for my first step, I chose to get rid of this x right here, which means this one needs to be multiplied by -3. When I multiply row 2 by -3, it becomes this. I brought row 1 over as is. That eliminates my x's. Add the rest together and I get this expression here. Going to the other side, I pick 2 other rows. So for this one here, I choose the bottom 2 rows. And for the x's to cancel, I need this to be a -5. So I multiply row 2 by -5 and I bring row 3 over as is. Add them together, x's go away, and I have this. At this point, I usually rewrite my system. Here's my original row 1, my new row 2, and my new row 3. I just like to see where I'm at right now. The third step is just add your 2 new rows together and get rid of y. And you can get rid of z if you want to, but I usually get rid of y. To get rid of y, this needs to be 4. So I multiply the whole row by 4, and I get this over here. I bring row 3 over as is. My y's cancel, and I'm left with 24z equals 192, which I go ahead and solve and get z equals 8. So now I rewrite the system one more time. I have the row 1, row 2, and now my row 3 is going to be z equals 8. From here, I just back substitute. I already know z. I got to go back one line, change z to 8, and figure out what y is. I did that over here. I changed z to 8, did the math, and now I know y equals -1. Well, once you know that, you just go back one more row and substitute 8 for z and -1 for y and figure out what x is. And I'm doing that right here. I substitute 8 for z, substitute -1 for y, do the math, and figure out what x is. Make sure you guys answer as an ordered triple. Your x number, your y number, your z number. 3 numbers in order, an ordered triple. Another example, add 2 rows and get rid of x. I chose to add the first 2 rows. This needs to be multiplied by -3 to cancel the +3. So I get these 2 rows, my x goes away. Going the other way, I choose to add the bottom 2 rows. To make the x go away, this needs to be multiplied by -5. So I multiply the whole row by -5, and I bring row 3 over as is, add them together, the x's go away, and I have this. New system, there's the original row 1, new row 2, and new row 3. Step 3 is add your two new rows together. All right, I choose to eliminate the y. I need this to be negative. Either one can be negative. I choose this one. So times -1, row 2 times -1 gives me this. I brought row 3 over as is. I meant to eliminate y, but I accidentally eliminated z as well. So look at what you get and make a decision. 0 equals 0, that's true. That means there's infinitely many solutions. Right below it we have this system here. Again, I'm going to add the top two rows, make x go away. That means this x needs to be -2. So multiply row 2 by -2 and bring row 1 over as is. Add them together, x goes away. I have this. I choose the bottom two rows. To make x go away, this needs to be -5. So I multiply row 2 by -5 and I bring row 3 over. Looks like this. Add it together. There's our new row 3. Here's my system so far. Original row 1, my new row 2, and my new row 3. Step 3 is add these two rows together and make the y go away. Well, to cancel, this one needs to be -2. So I multiply row 2 by -2 and bring row 3 over as is. I accidentally eliminated z at the same time. So look at what you got and make a decision. 0 equals 8. No, it does not. So no solution. Alright, some real quick determinants, down minus up, so that's 9 minus -9, get you your 18. Down minus up, 8 times -7 is -56, 6 times 0 is 0, get you -56. Down is 24, up is 24, 24 minus 24 is 0. Alright, the 3 by 3. Remember, I went ahead and rewrote these three columns because I didn't like the way the numbers were lined up here. So I kind of lined them up a little better. And remember, to calculate a 3 by 3, you have to copy the first two rows over. Now we do down, 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 up, up, up. And we're going to do down plus down plus down, minus up, minus up, minus up. So down, 4 times 0 times 8, 0. -2 times 4 times 2, -16. 1 times 4 times -4, -16 again, and now we do minus up, minus up, minus up. So up starts at the bottom and goes up. 2 times 0 times 1, minus 0. -4 times 4 times 4 is -64, so minus -64, and now minus 8 times 4 times -2 is also -64. Add those all up and you get 96. Alright, I'm on 143, same thing, a 3 by 3 determinant. Copy the first two columns over. I wrote this one a little bit more organized. So down plus down plus down, minus up, minus up, minus up. Guys, use the parentheses and you won't mess this up. Down, 3 times -5 times 1, that's -15. 1 times 9 times 3, that's 27. And -2 times 2 times 2 is -8. There's our downs. Up, 3 times -5 times -2. That's 30, so minus 30. The next up is 2 times 9 times 3. That's 54. And finally, 1 times 2 times 1 is 2, so our last one is minus 2. All right, so a better view at that. And that equals -82. Let's do the next one real quick. Copy the first two columns. Down is 4 times 1 times -1, -4. Plus, the next down, -3 times -4 times 6 is 72. Plus, the next down, 3 times 2 times -2, that's -12. And now minus all the ups. Minus 6 times 1 times 3, so minus 18. Minus -2 times -4 times 4, 32. And minus -1 times 2 times -3, 6. Add those all up, you get 0. Alright, real quick, solve this using Cramer's rule. And we went through one of these already, so I'm going to go real fast. So D is going to be 7, 2, 2, 1. dx, I'm going to take out the x numbers and put 0, -3 there instead. So 0, -3, 2, 1. And dy, I'm going to replace the y numbers with 0, -3. So dy is going to be 7, 2, 0, -3. And here I have them set up right over here. Down minus up is 7 minus 4. Down minus up is 0 minus -6. Down minus up is -21 minus 0. Here's my three determinants. Set them up like this, dx over d, dy over d. gives you these fractions, which reduce nicely. Okay, the last 2 by 2 is 255786. D is 2557. dx, take out the x's, replace them with 8 and 6, so 8657. dy, take out the y's and replace them with 8, 6, so 2586. Here they are, all set up over here. Down minus up, 14 minus 25. Down is 56 minus 30. And down is 12, up is 40, so 12 minus 40 gives you these three numbers. Set them up correctly, and then don't leave your fractions like this. Number one, two negatives make a positive, so we're definitely not going to leave that looking like that. And number two, you never leave a negative in the bottom. If you guys will just put these in with your fraction key on your calculator, it will tell you that this looks better with the negative on top, and it'll tell you that this looks better as a positive fraction. Alright, we'll make this the last one. 147 is this system here. Notice I have the answer numbers in orange. So I'm going to set up d, dx, dy, and dz, and then we'll go through the math real quick. So d is the original x, y, and z numbers right here. Copy the first two columns again so you have enough numbers to do your determinant. dx, notice that I took out 531 and I put the answer numbers in their place. And then you copy the first two columns again. dy, notice that I took out the y numbers and put the answer numbers in their place, and then I copied the first two columns again. And then dz, notice that I took out the z numbers, replaced them with the answer numbers, and copied the first two columns again. Now I'm not going to walk through all the math here, but I'll let you see what the numbers are. Down, 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 minus up, minus up, minus up, gives you negative 4. For dx, we have down, 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 up, up, up. Make sure you get all those minuses and negatives in there. Gives you 1. Last, let's see, dy, down plus down plus down, minus up, minus up, minus up. And dz, down plus down plus down, minus up, minus up, minus up. Okay, gives us negative 4 for d, 1 for dx, 39 for dy, and 27 for dz. Set them up like this. They're ugly, 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 and just make them pretty. This needs to be negative up top, that negative needs to be up top, that negative needs to be up top.